So, stoichiometry. Just get it. So basically, stoichiometry, all it is just determining the ratios of different things in a reaction and finding out how much you can produce from one thing, or if you have this much, how much is left over. So like, say a car has 4 tires. So you have like 4 tires, okay? And you have 3 cars, okay? So for every car, you have 4 tires, okay? So it was just basically like simple 3 cars. For every car, there's 4 tires, so it's going to be 3 cars would have 12 tires. Pretty self-explanatory. Not that bad. Alright, so when you actually get into reactions, there's different kinds of like questions you're going to be asked. Probably the simplest is going to be a mole to mole. So for a mole to mole reaction, you don't have to do much steps. It's pretty much just go from moles to moles. So on my periodic table, we'll go up here. Okay. So say you were to do this problem. So you're given 0.87 moles of aluminum, and you want to find out, to carry this reaction, how many moles you're going to have of hydrogen chloride. Or sorry, hydrochloric acid. Okay. So start off. So you have 0.87 moles aluminum. Alright? No. Sorry, one sec. Now, all you're going to do is, you can tell from the reaction, you want to find the moles. So your unknown, the one you're trying to always calculate for, is always going to go on top. So you have so the coefficients in front of the reaction is the mole ratio. I mean, you know by now, just a mole is just a unit for counting. So you have 6 mole HCl for every 2 mole of aluminum. Makes sense in the equation. This balanced equation, you need 2 moles of aluminum, 6 moles of hydrochloric acid to produce that, okay? Now, basically, all it is you're just multiplying across. So, I mean, 6 over 2 is going to be equal to 3, so it's pretty much just 0.87 times 3, which is 2.61. But it's just going to end up being 2.6 because of sig figs. You only have 2 over here. So you're going to only have 2 over here. So it's just going to be 2.6 moles of HCl. And that's all. That's the most simplest of the reactions you'll do, or equations. And then another type would be grams to moles, or you can also have moles to grams. So in this equation, for example, you are given the mass, which would be grams of, dinitrogen pentoxide, and you're trying to find out how many moles, what is that? Nitric acid. Okay, so you're given the 46.5 grams N2O5. You want to convert this into moles. Okay, so for every 1 mole of N2O5, you have now you're just finding like the mass of this, so it would just be 2 nitrogen plus 5 oxygen, which is going to be 108.02 grams. Now, you're going to do your mole ratio. So once again, you're going to have your unknown. You want to find out how many moles of this on top. So 2 moles HNO3 for every one, the coefficient 1, whenever it's left blank. Like it would be a 1 right here too. 1 mole N2O5. Now, that would give you how many moles of nitric acid. So then all you want is moles for this equation. So you're just going to finish right here, multiply across, be 46.5 divided by 108.02 times 2, and it's going to be 0.861. Again, you have 3 sig figs because of what's over here. So mole of HNO3. That's basically all that is. And like in the next type of equation, if you wanted to convert that into moles, all you would do is just set proportion would be one mole of nitric acid over the molar mass of nitric acid, and just one more step and cross multiply.